Salamun alaikum. How are you? Welcome to the class. Excuse me for my delay. I'm waiting for your friends to attend to the class. Can you hear me? Yes, okay. Let me share my screen to start the lecture. In the name of God. Uh, Dear friends, as you know, we are in the third part of our course, as I introduced before. In the third part of the course, uh, our aim is to talk about the design patterns and the role of design patterns in software engineering. Uh, in previous lecture, we started with this lecture, GOF design pattern, but due to a problem with my voice, we postponed the lecture to this uh, time. Okay. Uh, as I told before, we talk about the several design patterns. We have about 23 design patterns, different design patterns in GOF design pattern book uh, that they are classified into three different categories. The first category of design patterns is about creational design patterns. The second one is structural design pattern, and the last part or last class of design patterns are named as behavioral design patterns. All of them are good experiences about how to design um, my products and how to it will work uh, well. Uh, as I told before, a design pattern specifies a design problem and a best practice, a best solution to that problem. So a design pattern specifies a problem and then provide a solution to that problem. In this part, I hope we can talk about all 23 design patterns which are presented in GOF book. Okay, so we will talk about 23 problems, 23 different problems in software engineering in object-oriented design, and then we will learn how to heal those problems, how to solve those problems. Okay, with this introduction, we start this lecture. Uh, in this first slide talks about the principles of design patterns. The philosophy of design patterns is to emphasize on flexibility and reuse through decoupling of classes. Probably you know that if classes are connected strongly to each other, the product will not be flexible, and for any extension, for any new requirement, we have to redesign or change um most of parts of the system. Okay, so if we have coupling classes or connected classes, strongly connected classes, strongly dependent classes, probably we have a rigid structure in our product, and it would not be modifiable, and the extension will be a big problem in these products. Okay, so the aim of design patterns is to is to provide a flexible and modifiable system. Okay, but there are underlying principles that you should note to them. Uh, they are key points behind the design patterns to help us in designing a flexible and modifiable system. The first principle is to uh, program to an interface, not to an implementation. In design pattern, we focus on interfaces of our classes and how classes communicate with each other, not focus on how to implement, for example, one method of a certain class. Okay, so uh, we will focus on connections between our classes and interfaces that can interact with each other. Okay, the second principle is favor composition over class inheritance. In previous lectures, we talked enough about class inheritance, and talk about some concepts, some related concepts such as polymorphism, and we talk about the advantages of these mechanisms, and how they can help us to develop a robust and modifiable or flexible system. But in this lecture, we focus on composition. The composition is more important in this lecture than inheritance, because we want to have a collection of classes which have interactions with other classes, and uh, when we want to change a system, we want to add new requirement, to add new possibility, we have to change our system in most cases, but in this part of the course we try to design systems such that we can do our changes, we can provide our new requirements more easily than before. Okay. In this, the third principle behind design patterns is to find what varies and replay and encapsulate it. All varies all things that can change and change more ever, we can encapsulate those things so that we can define a better structure for our system. Okay, so with this uh, talks, we go ahead through introducing all categories, all classes of all three classes of GOF design patterns. As you see in this slide, we know that 23 patterns are divided in three separate categories. The first category is about creational patterns. The creational patterns deal with initializing and configuring classes and objects. Please note that in this category we have about if I remember it exactly. We have about six different design patterns that tells us how we can create our objects, how we can create our classes, or how we can instantiate our objects in different situations. Okay, so tonight we learn about two different creational design patterns named singleton design pattern and a factory design pattern, which are applicable in different situations in developing software products. So the creational patterns deal with initializing and configuring classes and objects. We have one creational pattern about configuring classes named factory uh, design pattern, and about five different design patterns for initializing our objects. The second category of design patterns is structural patterns, which deal with decoupling interfaces and implementation of classes and objects. Okay, and the third category is about behavioral patterns, which deal with dynamic interaction among societies of classes and different objects. And we will talk about these last two categories in later sessions. Tonight we just talk about the creational patterns, and we will apply those patterns in our case study, as you know, ATM case study. Okay. Uh, this table shows these three categories. As you know, excuse me, we have five design pattern in creational category, and uh, one of them is about configuring our classes, and four of them is about initializing or instantiation of our objects in software products. The first design pattern is about factory method, is named factory method. The second is for instantiation or objects, is named abstract factory. We have builder, prototype, and singleton design patterns. Uh, we talk about singleton design pattern and factory method in this lecture, and we continue to talk about later three design patterns in next session. Uh, but what about the factory method. The factory method defines an interface for creating an object, but let subclasses decide which class to instantiate. This means that when we have a class which has different subclasses, when we have an abstract class such as transaction in our case study, the transaction in our case study is an abstract class because all other, let me show you, as you remember from this design in our case study, we have a class transaction which has three different subclasses named withdrawal, deposit, and balance inquiry. You know that the transaction class is an abstract class because we have no any object of type transaction exactly. But in practice, when we want to define a transaction in ATM system, my transaction should be of type one of the subclasses. My transaction should be withdrawal or deposit or balance inquiry. So in practice, we don't have any object of type transaction, but all instantiation of transaction should be of one of these subclasses, of type of one of these subclasses. Okay, so in this situation, when we want to make an instance of transaction, we should define, we should use new keyword in Java, for example, to make an instantiation of one of these subclasses. So the factory method is applicable when we have an abstract class and several, such that we have several subclasses for that abstract class, and we have no any instance in practice of the superclass. Okay, the superclass is an abstract class. Let me come back to the slide. So the factory method define an interface for creating an object, but let subclasses decide which class to instantiation. Withdrawal instantiation, deposit instantiation, or balance inquiry instantiation. Not instantiate an object of transaction, of type transaction. The factory method lets a class differ instantiation to its subclasses. We talk about this factory method later, and we use this factory method for our case study. The creational design patterns for object instantiations, as I told just before, uh, is are abstract factory, builder, prototype, and singleton. What's abstract factory? The abstract factory provide an interface for creating families of related or dependent objects without specifying their concrete classes. We talk about this design pattern next session, and so for builder and prototype pattern. So we postpone to talk about talking about these three design patterns to next session, and in this session we will practice on our case study to use the factory method and use singleton design pattern. What is the singleton design pattern? The singleton design pattern ensure a class only has one instance and provide a global point of access uh, to it. What is the meaning of this sentence? What's the meaning of this definition? As you remember, in our case study, we have a class named bank database. And in our ATM case study, we just have an instance of bank database, not more than one. We have just one bank database object, not more than one. Okay. In this case, uh, we should be sure about making or instantiation just one bank database object, not more than one. How we can assure this subject? When you are in a team programming, when a team of people work on this project, we should be sure about have just one bank database object, and no one member of our team can make another instance of bank database in practice. How we can be assured about this subject? This is a problem that's solved in singleton design pattern. So tonight we talk about two design problem. One for making instantiations of subclasses of an abstract class, and one about to make sure that some classes in our system, in our product, to have just one instance in all over the system, not more than one. Okay, so let me go ahead to our implementation of the ATM case study. I defined a practice for you to make your own implementation of uh, the ATM case study, but most of your implementation is not correct, is not an object-oriented system, because in most of your implementation you have just one class. As I told before, in this design we have several classes. I'm surprised when I saw your implementation. Also, I have not checked some new submitted implementations. Uh, Please resend me again if possible, and I apologize for uh, my delay in investigating your homeworks. Uh, Nowadays, I'm very busy, and I have um, a lot of postponed work about my college, and uh, I couldn't, unfortunately, to check your answers, your new answers, but most of before submitted solutions are not corrected. However, tonight we talk about a good implementation in for our case study. Let me see your messages about the presentation you requested it before. We can send it. Uh, you can start your presentations from next session. In each session, I will talk about 1 hour, and we have half hour extra time to set for your presentation. So, if you are ready to present, to show your presentations in class, you can send me before, and I'll set a time for you to show your presentations. We have uh, no more time, and you should start your presentation. We should hold some extra sessions for those meetings that I didn't hold before. Okay. In WhatsApp, please send me from WhatsApp. No voice. Okay. About probably your net have problem, Miss Sarah. Probably your net has problem. Please check your net. Okay. Let me go ahead with my implementation and show you how to use these the two design pattern in our case study. Okay. Uh, as you remember from previous sessions, in our design for the ATM case study, we have some classes, including the ATM class, deposit slot, keypad, cash dispenser, screen, withdrawal, deposit, balance inquiry, transaction, bank database, and account class. And each of these classes have this description, have this definition in UML notation, and we should implement this definition in our IDE. As you see, this is my implementation from uh, Eclipse environment. In Eclipse environment, this implementation is of one of my student in San Andreas University, but I checked this implementation before, and it is a good implementation. So as you see, we have all classes in our design uh, model, model, as you see on your screen, and some extra classes. So we have class account. As you see, in class account, we have an account number attribute, PIN, available balance, and total balance. In banking system, sometimes available balance and total balance is not equal. Uh, Sometimes it could be happen that total balance is more than available balance. Someone may have a total balance which some part of his total balance could be blocked due some uh, problems such as he may have loan and some other problems. So the available balance may be different from total balance. And in this implementation, we consider these two attributes separately. As you see, the next part of this class is this method is a constructor. This constructor has about four different parameter to initialize the attributes of the class: account number, PIN, available balance, and total balance. And we have some other methods such as validate PIN when some customer wants to log into the ATM system. The ATM should can have to validate the PIN number and the account number and so on. The other methods, the other two methods, get available balance and get total balance, are two getters for these two attributes. And there are some other methods for credit, for debit of uh, the account, and get account number is a getter. Uh, Another class is the ATM class, and as you know, the ATM class includes uh, several attributes. Some of them are references to other classes such as a screen, keypad, cash dispenser, deposit slot, and bank database. These five, these five attributes are for making references to other classes. As you remember, if you remember, in our design lectures, we talked about these references. As you know, let me show this slide. As you know, in ATM class, we have to make references to other related classes such as deposit slot, keypad, cash dispenser, screen, transaction, and bank database. But you know that the transaction could not be initialized before any customer wants to work with ATM. The transaction class can be instantiated when a user enters to ATM system, and it should be initialized runtime. But in design time or in developing time, we should make references to these classes, these four classes, and bank database. Altogether, we have five references. We have to make five references. These references are implemented here in our ATM class. The other two attributes is about user authenticated and current account number. They are used when a user authenticated and can work with the ATM. This method is a constructor for our ATM, and the method run could be used to run the ATM, and some other uh, methods are implemented here You can see these methods later. We have other classes such as balance inquiry, bank database, cash dispenser, deposit, and as you see, we have a class named transaction. And as you see here, uh, the transaction class is an abstract class because we have no instantiation at all in our implementation in practice. So this is abstract class, and all instances of transaction should be of type of one of its subclasses: deposit, withdrawal, and balance inquiry. The transaction class, if you remember from our design model, the transaction class has a relationship to screen and bank database. And the row of this relationship starts from transaction and ends to screen. And this one starts from transaction and ends to bank database. So we have to make two references to these classes, to screen and bank database. To this aim, to do this aim, we have to make two references. These attributes are our references to screen and bank database. Please note that this screen is our instance in transaction class, and this screen is our class screen. The S of this screen is capital, and this is start with small s. This is started with capital S. This screen with capital S is the name of my screen class, and this is our instance in our implementation. And we have an extra attribute named account number for our transaction, as you see before in our design. Let me go ahead. In this design, transaction has account number. uh, Let me show you. Has account number attribute, and we have two extra methods: get account number and execute. As you see in this class, we have a constructor, transaction constructor, to initialize our uh, attributes, and get account number and get a screen, get bank database. These three methods are our getters, and we have an abstract method called execute. Why this method should be an abstract method? Why? Why this method has no any implementation in this class? Because in this class is an abstract class, and in practice we have no any instantiation of this abstract class, but all objects of type transaction should have the type of one of its subclasses. Okay, so in our subclasses, we should override this execute method. The execution of each type of transaction is different to other types. Okay, So each subtype of transaction has its own execution method. Okay. The other uh, so we have some other classes such as for example deposit. In deposit class, as you see, we define this class as an extension of transaction. This keyword this keyword defines inheritance relationship among deposit and transaction. The transaction is superclass and deposit is subclass. Okay. So as you remember, we have some extra attributes for deposit other than those inherited from transaction. Okay. These extra attributes include the amount of money we can deposit from our account, a reference to keypad, because in our design we have a reference from transaction to a screen and another reference from transaction to a bank database. So in our implementation we have two references. One, excuse me, uh, we have excuse me, two references, one from deposit to keypad and one from deposit to deposit slab. So in this implementation, these attributes define our references. And another integer variable is defined for some purpose which we will talk later. Uh, we have a deposit constructor. As you see, in this constructor, we should initialize all inherited attributes and all its own attributes. So first of all, we call the super class constructor. The super class constructor is defined in transaction class. The super constructors call this constructor. Okay. And after calling the super constructor, we can initialize other attributes in this constructor. And then we should override our execute method. The execute method for deposit transaction is different from, for example, withdrawal or balance inquiry transaction. Okay, so with the specific implementation for deposit is introduced here, is implemented here, and you can see it later. And some other methods are needed in practice, such as prompt for deposit amount, which is defined here, and you can see later. Another class that I want to talk about is about, for example, balance inquiry. As you see, balance inquiry is another class that extends the transaction class. As I told before, the transaction class has three subclasses. Okay. I'll send you this implementation and please compare this implementation with your own implementation. Okay. Mm, if possible, let me a moment to turn off my mic and I'll come back soon. Excuse me. Um, let me stop the recording and I come back soon. Excuse me. Sorry. Let me go ahead. Start screen share. Are you ready to continue the lecture? No problem. Can I start the lecture? Okay. All of you are online. Okay. Uh, let me to come back to our implementation. Another class, as I told you, is a, bank balance inquiry, which balance inquiry is an extension of transaction, and it has its own constructor and its own implementation of the inherited execute method. As you see, we have used override annotation to show that this execute method is the same as that one is defined in transaction class. In transaction class, we have defined execute method and we override it in our subclasses. And another class, as you know, is a bank database. The bank database includes several accounts. For example, in this case study, in this implementation, just two accounts is defined in the list of accounts of bank database for keeping for storing the accounts. We defined the accounts attribute and in bank database constructor, we initialize these two accounts in our account list. And some other methods that are used in practice when we work with uh, this ATM system and when we make some transaction and execute them. Uh, let me go back to our design pattern and we want to apply two of these design patterns in this case study. The first and the simplest design pattern that I want to talk about it is the singleton design pattern. A singleton design pattern make ensure a class only has one instance and provide a global point of access to it. Let me go ahead to its own specification for singleton. The singleton design pattern is the last design pattern in this uh, lecture. So let me go to its. This is the specification of singleton design pattern. The purpose of this design pattern, as I told before, is to ensure a class has only one instance and provide a global point of access to it. For example, each class that we want to be singleton class, it should have an static method named, for example, instance or get instance to return the only instantiation of the class, because singleton classes has just one instantiation, has just one instance, and that one instance should be returned some uh, some method such as by a method such as instance or get instance. The other operations is not important for us in this lecture. The only method in singleton, the only important method in singleton design pattern is the instance or get instance method, which should be static method. And we have to define some anesthetic aesthetic attribute named, for example, unique instance or simply instance attribute. These also should be static, because you know that static attributes and methods could be shared among all instances of our class. And as you know, in this case, we have just one instance in our type of our class, and this instance, this only instance, should be shared among all other classes to be used by others. So, the applicability of this design pattern, as I told before, use the singleton pattern when there must be exactly one instance of a class, such as happened for bank database in our case study, in our ATM case study. In our ATM case study, we have just one bank database, not more than one, and it must be accessible to clients from a well-known access point. This only instance should be accessed by an access point method. Okay. When the sole instance should be extensible by subclassing, this is not important in our point of view. The consequences of singleton pattern includes it provides controlled access to sole instance. I talked about this in my implementation. It reduces the namespace by avoiding global variables. It permits refinement of operations and representation through subclassing. It permits variable number of instances, and it's more flexible than class operation. We talk about these consequences after make our bank data making of our bank database as a singleton class. So we want to make this class as a singleton class. What change should be done in this class to make this class as an as a singleton class? This is an ordinary class. No, this is an ordinary class which has one attribute, a list of accounts, and constructor, and some extra getter and setter, and some useful operations. These operations is not important for us at this stage for this design pattern, except the constructor. The only constructor should be uh, changed to make this class as a singleton. For making a class as a singleton class, we should do three changes. Three changes are important, which we have to do to make a class as a singleton class. The first change that is needed is that we add a static attribute of type of the class. We should make an instance of this class instance okay, this is an instance of what bank database, and it should be static, and it should be private attribute. Okay, this is the first change. The second change is to change our constructor as private, because when this constructor be public, this could be called in all other classes. Okay, it would be accessible in all other classes. And when we make this method or this constructor as private class, it would be prevented. We make prohibit to access prohibition to access this constructor by changing this constructor as private constructor. Okay, we want to make access to this constructor just in this class, because we want to have just one instance of this class. This is the second change that is needed to make a class as a singleton class. The third change that is needed is to add an operation, a getter operation, uh, such as public static get instance. This is a simple getter which should be static, and this getter operation should be return an object of type bank database. The return type should be bank database. In this method, we should check the instance attribute of our class to be not null. If instance variable be null, we should instantiate this instance. So we should make this instance as new bank database. Okay. Mm, okay. And then return instance. Okay. What happened when we execute this operation? In this operation, first of all, we check your instance of bank database. If this instance has not initialized before, we should initialize this instance. Else, we return the existing instance. But this structure has no else part, because it's not needed. We do nothing in else part. So we uh, omit the else part. And finally, we return the instance. Now, this bank database class is a singleton class because we cannot make extra instances of the bank database. And when you save these changes, probably in your project you have some error. Yes, please note in ATM class you have one error, and this error happens when we try to make new instance of bank database. This is prohibited through what? Through changing, let me see, changing the constructor of bank database to private. As you know, when we change this constructor as private, we prohibit making any new instance of bank database. What we should to do at this time? As I told before, in all over this system, we have just one instance of bank database, no more than one. Okay, so in this situation, instead of making new instance of bank database, we call the get instance method of bank database to make access to the sole instance of bank database. So we call the static method of bank database by calling bank database dot get instance, and now your code is okay. There is no problem. In any other classes, you cannot make new instance. For example, let me to make new instance of bank database in transaction. For example, here we want to make new instance of bank database. We have an error, and it said us that the constructor bank database is not visible here because I change it private. So the only fix proposed here is to change visibility of bank database constructor to other package, or make this constructor as public. And we cannot change other classes because the bank database is implemented by other member of team. Okay, due to the open cloud principle, which I told before about it, we cannot change the implementation of other classes. Suppose the bank database is implemented by another person, and you should use it in the project without any change. You cannot change classes which are implemented by others. Okay, so we cannot define new instance, and we just can use the existing instance of one database in this class and other classes. So I want to conclude this talking about the singleton class. A singleton class is applicable when we have a class which should have just only one instance. For example, in this case study, bank database is a class that should be a singleton class. And the solution to ensure making just one instance all over the project by all team members is to use singleton pattern. And for for making any class as a singleton class, we should make three chains. The first change is to define an static attribute named instance, and the second change is to make the constructor of class as private constructor, and the second one making a static getter method named get instance, and in implementing this operation we should check if our instance is null. We should initialize this instance for the first time, and any other calls of this operation return the initialized only instance of one database. So this instance is the only instance of our class all over this project. Okay. Now, if you have any question, please ask your questions. Okay, no problem. Okay, I think we have no any time to talk about the factory design pattern. I want you to read about the factory design pattern for the next session, and please practice making your bank database class in your implementation as singleton class for to have exercise for this design pattern. This ATM case study is a good case study to using these design patterns in our course. And we can talk by example, we can define by example, explain by example various concepts in this third part of the course. I appreciate you for your attending to the class, and I think this is enough for tonight. If you have no any question, please let me to finish the lecture, and thank you for your attention. I stop the recording, and bye for now. في أمان الله. Okay, I'll send you the code. No problem, Mr. I'll send you the code.